Hi, I am Matilda Pretaeva, third year student, and this is video tutorials especially designed for statistics. Today we are going to prove that if two events are independent, then their complements are also independent. First of all, let's start with the definition of independent events. According to intuitive definition, events A and B are called independent if occurrence of one of them does not influence the probability of occurring of the other. Example might be event A, we will have a quiz tomorrow, and event B, that somebody will be killed in the Game of Thrones. So, formal definition says that events A and B are independent if the probability of their intersection, probability A intersection B, is equal to the probability of A multiplied by probability of B. So, in order to reach the goal of our video, which is to prove that the complements of two independent events are also independent of each other, we should demonstrate that the following equation is true. Probability A complement intersection with B complement is equal to probability A complement multiplied by probability B complement. We will start with the right hand side of the equation, which is probability of A complement multiplied by probability B complement. Using the complement rule, or in other words, we know that probability A complement is the same as 1 minus probability of A, and probability B complement is 1 minus probability of B complement. So we can open the brackets by multiplying out, and we obtain 1 minus probability of A minus probability of B plus probability of A multiplied by probability of B. We already know that events A and B are independent, so according to the formal definition, the product of their probabilities is equal to the probability of their intersection. And we can rewrite it and continue 1 as 1 minus probability of A minus probability of B plus probability of the intersection events A and B. We can pull out the minus sign and have 1 minus probability of A plus probability of B minus probability of A intersection with event B. As you can notice, this expression gives us probability of A union B. So we have 1 minus probability A union B. Again, we can use the complement rule and substitute this as probability A union B complement. Now I would like to stop for a moment and discuss De Morgan's law. De Morgan's law, it states that the complement of A union B is equivalent to the intersection of A complement with B complement. Let's try to prove that using Venn diagrams. Suppose that this rectangle is our sample space S, and these two circles our events A and B respectively. So I would like to use blue marker to denote the complement of A union B, which is everything that belongs to the sample space but does not belong to these two circles, A and B. I would like to use red marker to denote the complement of A, which is everything that belongs to sample space but does not belong to circle A. And I will use black marker to denote the complement of B. We see that the intersection of red color and black color coincides with the blue color, which proves that De Morgan's law is true and the complement of union A and B is the same as the intersection of A complement with B complement. So we can proceed and use De Morgan's law to prove that given that A and B are independent events, their complements are also independent. As you remember, we have stopped at this point where we have derived the probability of the complement A union B, and now we know what De Morgan's law is, and we can use it. And according to the De Morgan's law, we know that the complement of A union B is the same as the intersection of A complement with B complement. As a result, we come to the conclusion that probability A complement multiplied by probability B complement is exactly the probability of their intersection, which satisfies the definition of independent events. We reached our goal. Thank you for your attention. Follow us, watch us, and we hope that this video will be useful for you. Goodbye!